Hello, algebra students. Mr. Lawrence here, and this is your first review video. Now, by the way, for my template, I'm just looking at your review sheets and taking major concepts, and I looked over the first couple pages. Oh my goodness, 18 problems are all about slope, linear equations, etc. And the next couple talk about parallel and perpendicular lines. This video is going to be dedicated to slope and linear equations, and the next one will have parallel lines in it, etc., etc. So they'll help you do these things. I'll try to get as many done as I can so that you can get as much of this done as soon as possible. You can come in and ask questions. All right, so let's see here. Let's first of all remember, before we go to slope, that there are let's start with slope. I'm sorry. Slope. Remember the definition of slope? The definition of slope was rise over run. And the rise is your vertical movement, and the run is your horizontal movement. And there's a formula for calculating slope. Remember, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that equals m. Now in the midterm, I encourage you to do whatever it takes to get it right. You know, if you have to make a little sketch graph and count, but it's really effective if you know how to use this formula. Subtract your y's, subtract your x's, the y's, rise to the top. That's your slope. All right, so I've got two lines here already graphed for us, a green line and a black line with green points, and then a blue line. I want to know the slope of the black line. Well, let's see here. I'm going to count down to, because I'm going to move from this point A, so I'm moving down to, and then I'm going to move right 1, 2, 3. So the slope of that line is on negative 2/3, right? What's the slope of the blue line? Well, let's put a point on there. Let's call that point X, and we'll call that point Y. And it looks like on the blue line, I'm going down 2, just like I did. And then I'm moving over 0. Wait a minute, danger, werewolves. Deflector shields up. We cannot have a 0 in the denominator. This slope is undefined. You can never, ever divide by 0. Now look, don't be lazy. If you're a kid that gets it mixed up, pick up the calculator and type 2 divided by 0. You will get an error. If I do 2 divided by 3 or negative 2 divided by 3, I'm going to get a decimal. If I do 0 divided by negative 2, I'm going to get 0. If it's 0 in the denominator, it is an undefined slope. Vertical lines have an undefined slope. All right, so now I can do more with these. I can actually write the equations of these lines. But before I do, let's go ahead and remember the types of equations. Slope-intercept form, you should know. Y equals mx plus b. That seems to be our favorite. We use it most often. And when we're in this form, we know that m is the slope, of course. And then b is the y-intercept. Are you listening? Many of you are putting this on the x-axis. It goes on the y-axis. Yes, it's the y-intercept. If you want to call it slope y-intercept form, you can. Okay, it's not wrong. But it goes on the y-axis, not on the x-axis. That's why it's called the y-intercept. All right, standard form, if you remember that, that's ax plus by equals c, when a must be positive, right? Okay, point slope form is the one most of you forget. Point slope form looks like this. It looks like the slope equation. Y minus y sub 1. And then m times the quantity of x minus x sub 1. Now the cool thing about point slope form is that, well, of course we know the slope, right? But we also know a point. In this one we know specifically the y-intercept, but in this one we know the point, the coordinates x1, y1, and notice their signs changed. It was a negative y1, it turned positive, hocus pocus, and this was a negative x sub 1, and it turned positive as well. Okay, that point may be the y-intercept, but probably not. It could be any other point on the line. All right, so let's go back to our little equations here, our graph, I'm sorry. And I'm going to write the equation of the black line. Well, I know the slope is negative 2/3. I know the y-intercept is occurring at 1, 2, 3 at the point 0, 3. So therefore, b equals 3. In slope-intercept form, the equation of this black line is y equals negative 2/3 x plus 3. That's pretty simple. It's not so easy if you can't tell where it crosses the y-intercept. There's a little more work involved, and we'll do that in a second. Now the blue line, you should be very good at writing these equations. This is x equals 1, 2, 3, 4, 5. X equals 5. All right, if you need more practice with these, they're on that review sheet. Okay, now, if we're given 2 points without a graph, can we calculate the slope? Sure we can. M is going to equal the difference of the y's, subtract the y's, and subtract the x's. So x1, y1, x2, y2. So I'm going to take 13 minus 12. Oh, that's a hard one. Grab your calculators. And then I'm going to take 6 minus 3. Another hard one. Oh, Mr. Lawrence, you're so mean. I don't know how you can be mean to us. I go home and I cry at night because you give me problems like 6 minus 3. All right, so your slope is 1/3. Now, could we figure out the y-intercept? We sure can. We know that in slope-intercept form, we can take y equals mx plus b, right? If we could fill in a y value, the slope, and an x value, then we would have one equation with one variable, and we could solve for it. So let's do that. Which y you want to use? I want to use the 12. Okay. Then I'm going to use 1/3 of 3 plus b. I'm going to multiply 1/3 of 3 is 1. And then I'm going to get the b alone by subtracting 1. And so I will get 11 equals b. My equation in slope-intercept form is y equals 1/3 x plus 11. Now, some of you might be wondering, saying, Mr. Lawrence, I didn't want to use the 0.312. I want to use the 0.613. That's fine. Let's do it. Y equals mx plus b. I'll plug 13 in for y. I'll put 6 in for m. Oh, no, I will not. I'll put 1/3 in for m, excuse me. And then 6 plus b. I'll multiply. 1/3 of 6 is 2. 13 plus b. Subtracted 2. 11 equals b. Look at that. I got the same y-intercept. I'll get the same equation no matter which point I use. Okay? All right. Let's check out this one here. We've got an equation in standard form. Can we graph it? Well, before we do, I would say let's find the x-intercept. Let's find the y-intercept. And let's find our slope. Now, I'm not going to use all 3 of those. I'm going to use the 2 most friendly ones. Now, remember, an x-intercept is always some number, 0, right? A y-intercept is 0, some number. And then the slope, we can count on the graph. But I also taught you shortcut formulas. The x-intercept can be found by doing c divided by a. Remember, a, b, c. Okay, so in this case, c is on the other side of the equal sign. So 12 divided by 6 is 2. I think the y-intercept is 2. Let's test it. Let's put 0 in for y, so I'll get 6x minus 4 times 0 equals 12. I'll get 6x. This cancels out to 0 equals 12. If I divide by 6, sure enough, I get 2. X equals 2. Now, I just did that. If you didn't understand it, you better darn well ask me about it in class. Write the problem down. Go back and rewatch it. Ask yourself, what is he doing there? All right, let's try the y-intercept. Now, remember, there's a shortcut for the y-intercept. It's c divided by b. Okay, and c divided by b should be a -3. But again, we can prove it. Let's go 6x minus 4. Oops, I goofed there. In the y-intercept, we need x to be 0, so do 6 times 0 minus 4y, and that equals 12. That's 0. I'll divide by -4, divide by -4, and look at that, y is going to equal -3. Shortcut formula, long way to do it, plugging 0 in for x and y. So now I know my x-intercept and my y-intercept. I'm going to go ahead and plot them. The x-intercept is at 2, 0 right there. The y-intercept is 0, 1, 2, 3. Oh, negative 3, 1, 2, 3. There we go. Now, by the way, I can draw my line right now. I have enough information. I could go 1, 2, 3, 1, 2, I believe. Okay, and I'm going to draw the line. But a lot of times you might want to find your slope first. And I'm going to find my slope in 1 second. Now, if you were paying attention to me, you saw I kind of cheated. I just used my slope. Oh, Mr. Lawrence, you're sneaky. Sneaky, sneaky. But I'm doing it to prove a point. Okay, so there's your line. And you saw my slope was a rise of 3 and a run of 2. So therefore, my slope is 3 over 2. But if you remember the shortcut formula is the negative of a over b. Well, a is negative 6, b is negative 4, and that simplifies to 3 over 2. And see, I got the same answer. All right, very good. How about point-slope form? Can you write a linear equation in point-slope form? Well, we need y minus y sub 1 equal to m times the quantity of x minus x sub 1. To be able to do it, we need a y sub 1. Hey, I got one of those here, or I could use the 6, either one. Not both at the same time, that is. I have x's, I have a 6 and a 4. Now, by the way, if I choose the 5, I have to use the 6. If I choose the 6, I have to use that 5. The only problem is I don't know the slope. Well, let's figure it out. Let's subtract our y's, 6 minus 5, and then subtract our x's, 4 minus 6, and I believe I'm going to get negative 1/2. So my slope is negative 1/2. Now to write my equation, I'm going to write y minus 5 equals negative 1/2 times the quantity of x minus 6. Of course, I could have written y minus 6 equals negative 1/2 times the quantity of x minus 4. Now some of you are looking at me going, how can that be the same equation? Watch, they are the same equation. I'm going to take both of them and I'm going to convert them to slope-intercept form. All right, so first thing I'm going to do is distribute. And so I'll get y minus 5 equal negative 1/2 x plus 3, right? Then I'm going to add 5 to both sides. And so y is going to equal negative 1/2 x plus 8. Over here, I'm going to distribute of y minus 6 equals negative 1/2 x plus 2. Then I'm going to add 6 to each side. And I'm going to get y equals negative 1/2 x plus 8. And there you go. It's the same exact equation. So it doesn't matter which point you use. All right. How are we doing here? I think we're doing really good. Let me see here. Those are the 3 types of equations. All right, I think I'm going to end this video here, and I will make another one for your viewing pleasure. All right, Mr. Lawrence signing off. Have a good night, everybody.